Lesson 1-4 is going to show us how we solve an equation when it involves more than one variable. These are actually called literal equations, so let's write that down. And a literal equation is an equation that has two or more variables. So we can use inverse operations to solve those, just like we would other types of equations. The difference is that these involve more than one unknown. Probably the most common literal equations that you've worked with, even though you didn't realize this was the official name for them, are formulas. So, for example, when we say, oh, the area of a rectangle is length times width, that is a literal equation because it's got an equal sign and it's got more than one variable. Okay, this is a skill that extends far beyond algebra. It's actually a really important skill when you're working in science and data collection, like research, psychology, things like that. So it's very helpful. So let's go ahead and review. Really, the big idea today is nothing changes. And I think that's probably where students look at this and they think, oh, this must require a different process. Well, no, not really. So really the moral of the story is you're going to do what you always have done. The main difference is that when we were solving the equations before, as we isolated our variable, like for example, if we move this 8, we would combine it and simplify. So let's take number 1 as an example. First of all, when they say to solve the literal equation, pay close attention to what we actually want to isolate. Since there's more than one variable, it won't be as obvious which one you want to get by itself. So you'll want to make sure that you're looking at the directions or the word problem and know exactly who you want to focus your attention on. So yes, there's x's here, but honestly, right now we're not worried one bit about that. This is where the prize is, right? This is a variable that we want to isolate or get alone, that y value, okay? And so I'll pay close attention on that same side to what operations they did. So it looks like they took that y and they multiplied it by 5, and then they added 8, and we undo those. So that's the same process we've been doing. And we'll undo those or do the inverse operations, and we'll start by getting rid of that 8 like we're used to. Typically, we do the addition or subtraction first. So this first step will be very familiar, and if we do that on one side, we have to do it on the other. And that cancels the 8 here. I can, since these are numbers, I can combine that. I can say, oh yeah, those are both numbers, and -2 and -8 is just -10. So now I still have that 5x. These guys combine to a -10, and on this side the 8 is gone, but I still have that 5y. Okay. Then my next step is to get rid of this 5. Well, the opposite of multiplying is to divide, so I'll divide by 5. And of course, if we do that on one side, we have to do it on the other. And when there's more than one thing here, when we divide, we got to make sure we divide everybody. So everybody gets divided by 5. Okay, so that's what we mean by doing it on the other side. Not just to one term, but the whole side gets divided by 5. So that cancels and then leaves you y. And this is the only part that's a little bit different in the sense that, sometimes we simplify and we'll just still have a variable on this side, and that is okay. So as I divide here, 5 divided by 5 becomes just 1x, or just x. And then -10 divided by 5 is a -2. And so all of our steps, if you notice, were exactly what we have been doing. The only thing that students need to do now is get comfortable with leaving their answer, and I just kind of swapped that, but leaving their answer as not a final answer, but just a different organization of the original equation. So we got y by itself. We don't have a numeric answer because we don't know what x is, but we have accomplished our goal, which was to solve it for y, getting that y variable by itself and everything else on the other side. So whether you leave it like this or you rotate it like I did, both are perfectly acceptable. But this is the only thing that students just need to feel comfortable with. They're like, but it's not finished. Well, in this case, as long as we don't know what x is, you are done. You've done everything you could. You've gotten that y alone, and y is equal to whatever x is minus 2. Let's try one more. Let's look at number 2. Again, y, always focus so you're not like solving for the wrong thing by mistake. There's our y variable right there. And that's what we want to isolate. So this one's very similar to number 1. I look at what they did to y, and I do the inverse operations to that. So they have that multiplied by that -4, and there's the 7. We'll get rid of the 7 first. So that I'll align with my like terms. So now we've got 3x, and then +1 and a -7 is a -6. Okay, since those are numbers, I can combine them. And then here I have a -4y now. That's multiplication, so to undo that, we'll divide. And of course, again, we'll divide by everything. So if I divide on that side, that means this gets divided by -4, this gets divided by -4, everybody gets divided by -4. And so I get y equals, if this doesn't divide, you know what I'm going to say. You could go to a decimal and do more work, or you could just leave it like that as a fraction, which you know is going to be the way that I go because it's easier, right? And then here, a negative divided by a negative is a positive. And then 4 does not go into 6, but I can reduce that fraction. So 6/4 reduces down to 3/2. And that is as far as we can go. I've simplified it as much as I can. If it was a fraction, I've simplified it. If there were things that could be combined, I did. I did what they asked me, which was to get that y variable by itself. And other than that, we're finished. So again, not a hard lesson, and it really isn't any different. It's just sometimes for students it takes a while for them to get comfortable with the fact that this is actually an answer, and it's an acceptable answer. You're not always going to get an actual numeric answer, especially if there's more than one variable. Okay. All right, let's skip down to number 4 because this one's interesting. This does have a little predicament, the fact that the variable that we want, which is the y, is in the denominator. That's not good news. So let me show you how we are going to tackle that. So I'm going to rewrite it because it got kind of squished there. And that's a z. So this has 1, 2, 3 variables. Again, that doesn't really change our work. Our goal is to just keep our eyes on the prize. We're still solving for that y. This is what we want to solve for right there. Now we do have an issue. You're never really going to be able to get y by itself as long as it's in the denominator there. Okay, so we will have to fix that. So let's take care of first that 12. So since y is what I want to get alone, if they added that, if they subtracted that 12, we're going to add 12 on both sides to get this a little bit closer to being by itself. Looks like that. And since z plus 12, right here I could combine. When I added or subtracted, I had a like term. If you don't have like terms, they're going to just stay next to each other. So since I don't know what z is, when I add 12 on both sides, I'm just going to write, okay, well then z plus 12, sure. If I knew what z was as a number, then I could actually add that or combine it. But since it's a variable, I just leave them next to each other. In that way, I feel like sometimes this is even easier because you just write what you would have done, but you don't actually do it because you don't know what z is. All right, so here we are, but I'm still trying to get y by itself, and if it's in the denominator, that's a big issue. So now we're going to have to get it out of the denominator. So we're going to, the opposite of dividing by y is multiplying, and this isn't actually going to help us isolate it, but it's definitely going to help us solve it. We've got to get it out of the denominator. So I'm going to multiply by y here, and of course if we do that on one side, we have to do it on the other side, so the whole side also gets multiplied by y over there. Okay, this is an important step. Here, this cancels that. So even though I still have x equals, and that y still has stuff around it, at least it's no longer in the denominator. That was my primary goal. I have the x by itself, which is not what I needed, but it's getting me closer. Y is not in the denominator. And then all of this times y. So I'm going to write the y. I like to have it in front. But it's y times that sum. Okay. And then I can really tackle this now and see if I'm multiplying y by this sum, the opposite or the inverse of multiplying by this group of stuff is to divide by that group of stuff, by the whole thing. That's going to get y by itself. And if I divide on that side, I've got to divide on this side. Okay. So that whole thing cancels out. Now I have y alone. So our answer is x divided by that sum of z plus 12. And then since I'm using a long division bar, I don't need the parentheses, but you can write it if you want. And that is equal to that y value there. So that's probably one of the more challenging ones there. And we'll do a few more like that here in a bit. Let's try number 7. So just to kind of mix it up a little bit, notice now we are solving for x. So that's just to get you into the habit of always paying attention and making sure you're solving. This has some G's, some R's, so it's got a few things here. And this is the one we want to get alone, just that x right there. Okay, so let's try it. I look at the operations that are around it, and I start to do the opposite, starting with the number that's, or the term that is not directly connected. So I'll tackle this first. This 2r, we're going to get rid of it with a negative 2r, and I'll line it up with my like term, like that, and that cancels. So now I have 4g, r, which is really a positive 1r, and a negative 2 is a negative 1r. So positive 1 and negative 2 is negative 1, or just negative r. And on this side, I still have that negative 2x. And then the next step is to get rid of the negative 2. Since you're multiplying by it, we are going to divide. Divide, divide, all the way across. So 4 divided by negative 2 is negative 2g. Negative 1 here divided by a negative 2. Double negative becomes a positive, and then 1 over 2 is just a half, or 1/2 r. And then the x is by itself, and that's it. As long as that x is by itself, it doesn't matter how pretty or ugly this is. It just really depends on how many variables you have. That is all you are required to do to solve for x. So you won't actually get a real answer, like numerically, just basically a different organization or version of the same equation. Okay? So those are the steps. I hope what you're getting from that is the steps are really the same. They might look a little different, and it might take your brain about 24, 48 hours to kind of like adjust and be like, oh, it's okay to leave things sort of quote unquote, some students say, but it's so messy looking. But that's okay. If we don't know what these variables are, there's nothing you can do about that. You've done your job, which was isolate that variable. Okay, let's go ahead and see that in action in some actually common formulas that typically come up, like geometric formulas or algebraic formulas, and things like that. So it says solve the formula for the indicated variable, and this is the formula for the area of a triangle. So it probably or hopefully looks familiar to you. The area of a triangle is always 1/2 the product of the base and height. We want to solve that for b. So what I want to remind you one more time is that we're not really like solving it for an actual answer. We're more reorganizing this, right? Typically you see this formula solved for a. It tells you what the area is. All we're doing is reorganizing it in a mathematically legal way so that instead of the a being by itself, the b is by itself. Okay, so let's do that one. So we've got a equals 1/2 times b, and then times h. And right now, the variable that we want by itself is b. So we're just reorganizing this, okay? So let's start to work on that. Well, let's start with a fraction. We've talked a lot about over the last several days what happens when we multiply by a fraction. If I want to eliminate that, when we're multiplying by a fraction and I want to get rid of that, we instead multiply by the reciprocal. So the reciprocal of 2 over 1 is just, of 1 over 2 is just 2 over 1. I got ahead of myself there. 2 over 1, and if we do it on one side, we do it on the other, okay? But multiplying by the reciprocal is just going to cancel that out. We've done a few of those now. So the fraction's gone. Now I just have base times height is equal to 2 over 1, which is just 2, times a. So now we've got just 2 times a here. So all we're saying is if the area is half of this product, then that means this product must be twice the area. That's pretty logical. That makes sense, okay? But then we still want to get b alone, right? So if it's b times h, that gives us 2a, then the opposite of multiplying by h is to just divide by h. And if we do it on one side, we have to do it on the other. Boom. So the base is twice the area divided by the height. And that is an absolutely true and accurate statement. So you're used to seeing this formula in terms of area and having the area isolated. And you probably already knew that the area of a triangle is always 1/2 the base times the height. And now you've discovered that it's also true that the base of a triangle is always equal to the area times 2 divided by the height. That's always true also. So that's your sort of new reorganized formula. And this is where it can really come in handy. Changing and manipulating formulas, especially in your science classes and classes like physics and so forth. Okay, let's do one more. I told you we would do one more with that variable in the denominator. So here, this is Ohm's law. You will study this in physics. And it says I equals V over R. I believe this is like current and voltage and resistance, things like that. But it doesn't matter. You don't have to you don't have to know the physics of it. You just have to keep your eye on the prize here. We want to reorganize this very famous formula so that the R is by itself instead of the I. Okay, so that's our goal. So currently, this is typically presented like this, and our goal is to just have R by itself instead. And very much like number, let's see, that was number 4. A big predicament here is that the variable that we want is in the denominator. And that typically should kind of sound off a little alarm that, oh, no, that's not good. We got to fix that. So we're going to multiply by R to bring it up. Of course, if anything we do on one side, we do on the other. And that doesn't really isolate R, but it does help us get it out of the denominator, which we want to do like our life depends on it. We really need to get that out of the denominator quickly. So multiplying by R on both sides cancels it on the right. And on the left, we get R times I, which is okay. R times I. Did not isolate it, but it got it out of the denominator, and that is a big step forward. So now we're here. And once we're here, then it becomes really a lot easier. Now I can really think about how do I get this by itself? Well, they're multiplying it by I, so the opposite of that is to divide by the I. And that cancels. So it turns out that the same law can tell us that R is always equal to V over I. And that is the same relationship, just reorganized a little bit. Okay. Let's try number 15. We might finish off with that one. Maybe do a word problem in class as a warm-up. So for this one, we want to solve it for Z. So here's Z. The reason I want to make sure we do this one is because it has an exponent. I want y'all to see how we handle that. So there's our Z. So our goal right now is to take this equation and get that by itself. So again, we'll start with what is not directly connected, whatever's added or subtracted. We start by getting rid of that. So I want to get rid of that whole term. So I'm going to move that entire term with a negative xy on both sides. Okay. So when I want to eliminate the entire term, I'm just going to do that opposite sign. This cancels. So that leaves me with z to the second power is equal to, and since these are not like terms, I just leave them next to each other, like such. And really, this is pretty close already, isn't it? I mean, that z looks almost by itself, but it really isn't quite by itself if we have that power. It's not fully isolated. So we want to undo the exponent. So what I want to remind you is that the opposite of squaring is square rooting, the square root. So the inverse operation that's going to eliminate my power is a square root. And if I do it on one side, I have to do it on the other side. Y'all knew that was coming. Okay. So here, the square root and the square, they are opposites. They're inverses. They undo each other. They're gone. And that leaves my z fully isolated. So it turns out that z is simply the square root of 3 minus xy. And that is as much as we can do. And we have to do. We don't have to do anything more than that. Z is isolated, and we are good. So it's the same inverse operations. It just looks a little different. It takes one day or two to kind of get used to that concept, but a really, really important skill because being able to manipulate formulas is a huge topic, okay? And then we'll take care of number 16 as our warm-up in class.